The mean value theorem, keeper 5.4. Alright, first I want to show you guys Rolle's theorem, and then I'm going to show you the mean value theorem. Rolle's theorem and mean value theorem are very, very close to each other, very similar ideas, very similar concepts. So I'm just going to show you both at the same time pretty much. So Rolle's theorem basically says that if your function is continuous and your function is differentiable and your y values at 2 points are exactly the same, then you must have some place in that interval from a to b where the derivative equals 0. In other words, where your derivative is horizontal. So that seems a little confusing, but if we look at it graphically, we have some point A and some point B. They have the same exact y value, and because they have the same exact y value, their slope is going to be 0. Well, in order for me to travel along this function, come to A, and then get back to B with the same y value, I had to have a max or a min there. So that tells me that I had to have somewhere else in that interval where the derivative also equals 0. So again, if A and B have the same y values, then that means that the derivative or the slope of the line from A to B is 0, and therefore I must have some derivative function at C, some value C, someplace in that interval where the derivative also equals 0. Now, the mean value theorem basically states the exact same thing, except for the mean value theorem is a little bit cooler, because not only do we have can we say that equals 0, but we say that there's somewhere in the interval where the slopes match. So again, if our function is continuous, if our function is differentiable, then there exists some number c between a and b such that the derivative at c equals the slope from a to b. So remember this formula, f of b minus f of a over b minus a, that's just your slope, or the slope of the secant line. So again, looking at that visually, I have some curve, I have an a value, I have a b value, and I can find the slope from a to b. So this orange line that I'm highlighting is the slope of the secant line. That's your normal slope from a to b. Well, all this theorem is saying is that there's some place on this interval that has the same exact slope. And so and I should be more specific, not just someplace on the interval, but someplace on the interval has a tangent line with that same exact slope. So looking at this picture here at C, our tangent line, which touches the graph exactly 1 point, looks like it's parallel to the secant line, and those two things do have the exact same slope. All right, so here's our example. It says determine all numbers C which satisfies the conclusion of the mean value theorem for the following function. Now, in order to do this, again, you have two conditions. Your first condition is that it is continuous. And since it's cubic, I know that for sure it's going to be continuous. Next, I want to know that is it differentiable? Yes, this function is differentiable. Now, notice on continuous, I use closed brackets versus on differentiable, I use open brackets because I can't be differentiable on an endpoint. All right, so because it's continuous, because it's differentiable, I know there has to exist some c between -1 and 2, and I know that the derivative at c has to equal the slope from -1 to 2. So f prime of c must equal f of 2 minus f of -1 over 2 minus -1. Now, first finding the derivative of my function at c, I get 3c squared plus 4c minus 1. And then finding f of 2 and f of -1 for my slope side, or my right side of the equation, I get 14 minus 2 over 3. Simplifying that right-hand side, 14 minus 2 is 12. 12 over 3, I get 4. Subtracting 4 on both sides of the equation, I get 3c squared minus 4c minus 5 equals 0. And then I would try or attempt to factor this. However, this function does not look factorable. So what I'm going to do is I'm going to use the quadratic formula. So I have negative b plus or minus square root of b squared minus 4ac all over 2a. Plugging in those values, I get 4 plus or minus 16 minus 4 times 3 times -5 all over 6, which simplifies down to 2 plus or minus root 19 over 3. Now the question is, do both of those values fall in my interval from -1 to 2? If so, then they're both the answers. But if not, I need to figure out which one falls in the interval. So looking at this, I know that the positive one would not fall in the interval because my interval ends at 2, and the positive is 2 plus some number, so that would fall outside the interval. Therefore, my only solution is the negative solution, which would be 2 minus square root of 19 over 3. All right, next example says, suppose that we know that f of x is continuous and differentiable. That means it satisfies the two conditions for the mean value theorem, and this is true from 6 to 15. So it says, let's also assume that we know that f of 6 is negative 2, and we know that f prime of x is less than or equal to 10. What's the largest possible value for f of 15? Well, setting up my values into the mean value theorem, we know that the slope has to be less than or equal to 10, because I know that my slope has to equal my my slope of the secant line has to equal the slope of the tangent line. And since the slope of the tangent line is less than or equal to 10, that means the slope of the secant line also has to be less than or equal to 10. Now, plugging in negative 2 for f of 6, I get f of 15 plus 2 has to be less than or equal to 90 by simplifying my denominator and multiplying on both sides. Next, I will subtract 2 on both sides, and I get f of 15 has to be less than or equal to 88. Therefore, the largest possible value for f of 15 would be 88. All right, next example, we have let f of x equal sine 2x plus cosine x. It says use your calculator to find all values of c that satisfies the conclusion of the mean value theorem for x between 0 and pi. All right, so number one is continuous because sine is continuous and cosine is continuous. It is also differentiable because I have no cusp, corners, or vertical tangents. Again, noting that I'm using parentheses for differentiable and brackets for continuous. Setting up my mean value formula, first working with the secant line, we'd have f of pi minus f of 0 over pi minus 0. Plugging that into my equation, I get negative 1 minus 1 equals pi, or negative 2 over pi. Now to find f prime of x, or f prime of c, we have 2 cosine 2x minus sine of x. And again, I know that has to equal the slope of the secant line, so it has to equal negative 2 over pi. Now, I don't want to work this out. I don't know how to do it. It looks like really, really crazy math, so I'm just going to use my calculator. So using your TI Inspire CX Cast, you can type solve into your equation, open parentheses, type in your equation equals negative 2 over pi, comma x, close parentheses, press enter, and it will solve it out for you. And once you do that, you should get that x, or in this case c, has to equal 0.7704 and 2.3712. And those are the only two values that fall in the interval from 0 to pi.